Uh, I wish there was like a thing to let me know that I was recording. So I did motor kits 4 and 5, and here are its questions and how they work. So I did motor, like I said, 4 and 5. Motor kit 4 it's very simple, and it's a pretty strong motor. Very limited, materials. Pretty much all there is a switch and an electromagnet just to make it move. But once the source is plugged in and the magnet is near the reed switch, right here, the circuit completes and it closes, allowing the electromagnetic to be turned on and moving this magnet on the rotor, and thus moving the shaft and creating a moving rotor. This happens up until this magnet right here moves away from the reed switch. The reed switch opens, the circuit is opened again, so that way that this magnet does not interfere with the magnet that's coming to it yet again. So that way the electromagnet can, I guess, receive the magnet and then push away the magnet yet again. Pretty nice, pretty simple, and a pretty effective motor. Motor Kit 5 is pretty much the exact same thing with a few tweaks, and it works by with a capacitor and a transistor. It's a little bit better, and it works on higher voltages. It's pretty much the same thing. Once the magnet is near the reed switch, the electromagnetic's turned on, and current is flowing from not current. The rotor is moving and completing the circuit. But this time the circuit doesn't completely rely on the reed switch. It has a transistor to supply current, making it a little bit better and a little bit more efficient and more capable, and increasing its lifespan overall. So in both cases, motor 4 and 5 are they don't have really any brushes connected to the power supply, and the armature is also not connected to the power supply. So neither do they have stators. Is completely hollow within the rotor. It is just completely powered by the magnets and the electromagnets on top. There is nothing going on inside, at least to my knowledge, of these kit motors. So if you switch the polarity of the battery, does it rotate it? In both our cases, switching the polarity would not change the direction of the shaft. Really, the only way to change the direction of the shaft is to change the armature coil, and does the torque at your motor shaft change? How does it change? The torque of the motors only change when they're turned on or off. That initial torque is really the only change in torque. Once it reaches that final that once it gets going, I guess is what you would say, the torque is pretty much constantly at its peak, a continuous torque. And this would be the case for both the motors, and would only really differ if it was under an AC motor. How would you do the destruction testing? Destruction would be kind of tricky. I can't really see the motor, and I can't really do everything I'd like to do with the motor. But what I would do is I would increase the current power supply. Make the motor move extremely fast until it begins to break, or it's unable to handle it due to materials. And then make sure I jot down that that current, that power supply, the distance between the magnet and the reed switch, and pretty much everything that you can do to increase the speed, and jot that down, so I know that would be a little over the maximum speed the motor is able to withstand, because the motor can withstand a little bit more power than it's capable of, but only for a short period of time. Yes, this motor does self-start. It self-starts because the magnet. It will self-starts if the magnet is near the reed switch. If the magnet is not near the reed switch, then I don't see any way that it could start. But it does start if it's near the reed switch. Does the motor self-stop? The motor would continue to move unless the reed switch is, it gets it wears down. If there's an outside interference, otherwise the motor will continue to rotate and be under that high level of torque. I would like to load my motor with a boat. Not with a boat, but I'd like to use an example with the boat and its propeller, being able to push forward the boat, and depending on the water current, whether the water current is going with the boat or whether the water current is going against the boat, I feel like that'd be pretty cool example to see and see how the motor reacts and whether it goes under extreme stress or extreme loads rather, and is able to compete, or not compete, but to compensate. And I'll see how much water current you're able to move forward against. Like that'd be a pretty cool experiment. You can control the speed of the motor by changing the flux or the current through the field winding. This is a pretty simple fix. You can do it by adding a MOSFET, to control the current going into the electromagnet, or you can just add a potentiometer, something really simple like that, increase the resistance, decreasing the current, simple stuff like that. But in this case, we could do something even simpler by just moving the magnet closer to the reed switch, which allows for faster switch timing and thus increasing the speed of the motor. So you could measure the RPM of the motor by using the equation frequency equals P over 120 times N, where N is the RPM. Just solve for N in this case, and it'd be 120 over P, your poles, and Fe is the electrical what's the word? Frequency. No. You expect your motor to work under AC power? Yes, I would expect my motor to work under AC power. I feel like it'd be really choppy. The motor would have like short bursts of power, depending on how long the period is for the current. And I feel like this is the case because there's really no parts that really depend on AC or DC. It's really just based on whether the electromagnet is on or if it's off, if the switch is open or if the switch is closed. There's really no inductors, there's really no capacitors, except in motor 5, but the capacitor is only there to help with the transistor and smoothing the overall voltage. How would you turn your motor into a generator? Now this is a pretty tricky question. So pretty much you'd want to do the opposite. From what I understand, you'd want to, I guess you could hand crank the magnets, and I guess as fast as you possibly could, or and then induce a current. I think connect the current to a voltmeter to see how much, or like a light bulb or an LED or something to see how much current you're producing or how much voltage you're producing. And I feel like it would be a very small amount of voltage due to the fact that it's kind of inefficient at that point. And that is the end of my slideshow. So thank you very much for listening, and I appreciate it.